All right, in this video, we are going to find the limits of these functions over here, and then we are going to sketch the graphs out and verify that our limits are correct. So let's take a look at the first question here. We have the limit as r approaches -4 from the positive side. Then we have this rational function over here. So I'm going to just start by factoring that function because it is possible to factor it. And now it's not really possible to simplify. I can't really cancel anything out. So let me sub in my limit into this function. And I'll just get -2 over 0. Now, -2 over 0 can basically be plus or minus infinity. It doesn't have to always be negative infinity. It can be the opposite as well because, again, -2 over 0, that just means there's a vertical asymptote over there. And when we have a vertical asymptote, we can either approach positive or negative infinity. So you can't assume one of them is the right solution. So how do we know which one it's going to be, whether it's going to be positive or negative infinity when we're approaching -4 from the positive side? Well, if we have a calculator, what we can do is we can sub in a value slightly larger than -4 into our equation. So I'll just sub -3.99, which is a number that is slightly larger than -4, because from the positive side means pick a number that's slightly higher. And then I'll put this in my calculator. And I get positive 25, which means that my solution is positive infinity because it can either be positive or negative infinity. So I know that as I'm approaching -4 from the positive side, my graph is approaching positive infinity. So now I'll verify this by doing the graph of this diagram. I know that in this graph, when I factor it, I have two vertical asymptotes there. My vertical asymptotes are at r equals -4 and r equals +4. The degree on the top is greater than the degree on the bottom. So I know for my horizontal asymptote, it's just y equals 0. I'm just going to sketch it out here, but if you have graph paper, you can graph it more accurately on that. So I have vertical asymptote r equals -4, vertical asymptote r equals +4, and then I have a horizontal asymptote at y equals 0. So now in order to sketch this out, I need to pick a couple of test points over here to know whether I'm above or below the graph over here. I'll start by picking -5, and I'll sub in -5 into my original equation. If I sub in -5, I get -2 over 9. -2 over 9 is below over here. So I know that the graph has to go like this and hug the asymptote. And then I can sub in -3.99, which I already did over there. When I subbed in -3.99, I basically got 25, which is somewhere over here. So I know that the graph is going somewhat like this. Then I'm going to sub in a value slightly below 4, so I can sub in 3.99 for that one. And for that one, I get again 25 approximately. I'm just rounding it. It's 25.03. So I know that this just goes like that over there. And then I just want to pick one last point here. I'll pick positive 5. And if I sub in positive 5, I get negative 2 over 9 again, just somewhere over there. So I know the graph just goes like that. And that is my graph or sketch for this function over here. As you can see, as r approaches negative 4 from the positive side, that's from the right side, the y value is going up towards positive infinity. So my limit for this question is positive infinity. Let's try the second question over here. In the second question, we have 2 tan r. So this is just a regular tan graph. We know that a tan graph has a period of pi. So we know that it repeats every pi. And we know that for a tan graph, a vertical asymptote, our first vertical asymptote starts at pi over 2. So first things first, let me sub in the limit into this. There's no simplification that I can do here. So if I sub in negative pi over 2, I know this is not going to work because this is my vertical asymptote. And if you put this in a calculator, you'll just get math error. Make sure your calculator is in radian mode. So we know that this is not possible. We know that there's a vertical asymptote over there, which means my answer at a vertical asymptote always has to be either positive or negative infinity. But again, to determine which one, mathematically, we'd have to sub in a value into the equation, and then we can verify that with our tan graph as well. So I'm going to sub in a value. It's again from the positive side. So you want to sub in a value slightly larger than negative pi over 2. So I'm going to sub in negative pi over 2 plus 0.01. That's again the same thing that I did in that first question. I'm just subbing a value slightly higher. And now my answer should either be positive or negative infinity. If I put this in my calculator, I get negative 199.99, basically negative 200. So that is approximately negative infinity. So I know my limit for this question is going to be negative infinity. But let's do our graph, double check that in our tan graph. So you should know how to sketch a tan graph at this point of the course. You've probably learned it in the previous course, advanced functions, but you should know how to sketch a tan graph. A tan graph has an asymptote at negative pi over 2, has another asymptote at positive pi over 2. And it basically goes like that and repeats forever. Basically, both directions. Now, if we look over here at x equals negative pi over 2 from the positive side, which is the right side, you can see that the graph is going down, which means that the limit is approaching negative infinity, which correlates to the exact same answer that we got over here. So we know this is correct. And let's go to the third and final question of this video. In this one, we have, again, a rational function here. Nothing to really simplify. I can't really factor or cancel. So I'll just start by subbing in my limit. So I'll just get negative 3 over 0, which again is either positive or negative infinity. But which one is it? Now, for this one, we don't have a left side or right side limit, so we actually have to figure out both side limits for this one. Let's start with the left-sided limit. Lim x approaches -3 from the negative side. That's the left-sided limit. So for this one, what I'm going to do is I'm going to sub in a value slightly smaller than -3 into this equation. So I'll do -3.01. If I put this in my calculator, I get positive 301, which means this is approaching positive infinity. So the left-sided limit is approaching positive infinity. Let's do the right-sided limit next. That's lim x approaches -3 from the positive side. Anytime you're a vertical asymptote and they don't give you a left side or right side limit, you have to do both sides. So I'll pick a value slightly larger than -3, so I'll pick -2.99. I'll put this in my calculator. And I get -299, which is negative infinity. So if the left side limit approaches positive infinity and the right side limit approaches negative infinity, it means that the two limits are approaching different areas, which means that in this question, the limit does not exist, because if your left side and right side do not approach the exact same value, the limit does not exist. Finally, let's plot a graph of this function. If you look at the original function over here, we have a vertical asymptote at x equals -3. That's the solution to the denominator. We have a horizontal asymptote at y equals to 1, because the degree of the top is the same as the degree of the bottom, which means I'm dividing coefficients. So 1 divided by 1 is 1. So vertical asymptote at x equals -3, horizontal asymptote y equals 1. And then I know that when I did my left-sided limit of -3.01 was going up to positive infinity, which means it's somewhere over there in the graph. Just looks like that above, hugging both asymptotes, basically. And when I did the right-sided limit, it was approaching negative infinity, which is down over here. I know that the graph just goes like that on this side over there. And as you can see, that at -3, that's going up, that's going down, which means the limit does not exist. For the limit, the two-sided limit to exist, they have to either both be going up or both be going down in an asymptote, and then you would have a limit. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.